Okay, good morning. Welcome to
KidMath number 90.
KidMath number 90. This, I think, is the fourth movie in our series about the area inside of a parabola that you asked me about the other day. Right, we're trying to calculate or trying to see if the area inside the parabola is bigger than, less than, or equal to the area outside of the parabola. And so we've been talking about it a lot of different ways. So you remember probably 2 videos ago we drew some lines in like this. And we found that the area inside the lines was 1/3 of the area outside the lines.
Yeah.
And then we weren't sure what happened at infinity, but anytime we stopped and drew a square
At a finite spot.
we always got 1/3 of the area here and 1/3 of the area outside, or 2/3.
There was a quarter in here and 3/4 out.
Sorry, yeah. Yeah, right. 1/4 in, 3/4 out. The ratio was 3 to 1. That's why I was saying a third. But 1/4 in, 3/4 out. Yes. Okay? So we're going to do the same thing. We're going to really try to do the same thing with the parabola. So what we're going to do is we're going to try to draw squares. Okay? But it's a little tricky to draw a square with a parabola because if I go out to a point x, I go up to x squared, which is not the same, right?
Yeah.
X and x squared aren't the same.
Except if x is 1.
Except if x is 1. Right. So what I want to do is I want to draw, probably didn't draw my parabola very well, so let's draw a correct parabola so you can see the distortion. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So from goes 1 to 1, but at 2 it's all the way up here at 4, right?
Yeah.
So it actually goes up really fast. And up really fast on this side. So that if I want to draw a square that's 4 by 4, that square is going to look like that, right?
Yeah, then we have that area. But it's hard to calculate that area.
Yes, it's very hard to calculate this area. And the first thing we have to do is calculate the area under the parabola because this is just a rectangle, right?
Yeah.
This is a square. This is a square. This is a rectangle. So if we can figure out how to calculate the area underneath the parabola, for example,
It'll be really easy.
we'll be able to calculate the area outside of the square, and then we'll be able to figure out the area inside of the square because we know the area of the square. Right?
Yeah.
Okay, so first thing we're going to do today is talk about the area under a parabola.
Alright.
Which means I have to erase one more time and go back to the drawing that I originally had and see if we can figure out how to find this area. Okay? And this, by the way, goes back to Archimedes. This is something usually studied in calculus now, but the ancient Greeks actually knew how to do this. And so the cool thing you do, and why this is such a fun example and used a lot in math, is we're going to break this down to a problem that we know how to do, which is areas of rectangles.
Yeah, that's easy.
Okay? We don't know how to find areas of curves or areas under curves, but we do know how to find areas of rectangles. And so what we're going to do is we're going to chop it into rectangles. Maybe cut it in half like that and draw 2 rectangles. Okay? Now, those 2 rectangles are approximately the area under the square,
Yeah,
under the curve,
You've got these.
but I got some big gaps. Okay, so how could I do better?
Draw more rectangles.
Draw more rectangles. It's the only thing we really know how to do, right?
Yeah.
So our only hope is that maybe draw more rectangles to get a better approximation. Maybe I cut those in half. Hey, I do have a better approximation because last time I had this area outside and this area outside, and now I'm a little bit better. Oops, I forgot to draw that one. But I'm still not perfect.
Yeah. So you need more.
Need more. Cut it in half again. Yonk. Yink, 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 yink. Yonk. Yink, 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 yink. Yonk. Yink, yink. Yink, yink. Yonk. Yink, 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 yink. And so you can see
You get a better and better approximation.
I get a better and better approximation. And all I have to do is add up the areas of those rectangles
But you need
that are getting smaller and smaller.
But you still got like this tiny little bit.
Right, so what should I do next?
Chop it in half again.
Chop it in half again. Chop it in half again. Chop it in half again. So I reduced the problem to adding up of the area under the curve to adding up the area of a bunch of
You have
rectangles.
infinity rectangles.
Yeah, you have infinity rectangles eventually. If you got to get it perfect, your rectangles are going to be so thin
You can't see them.
you can't see them. But it looks like it works, right?
Yeah.
And here's the cool thing. It does work. It does work. Now, I don't want to go into all the details about this, okay?
Alright.
Because this is what you study in calculus, and it's a little more complicated than you need to know for now. But it's going to turn out that this area under the curve from 0 to x, area under y equals x squared from 0 to x, is x cubed over 3. It's going to turn out all this chopping and splitting and summing and then infinite rectangles gives us a nice, beautiful answer. X cubed over 3.
How did that happen?
Yeah, well that's what calculus is going to teach us. So with this result, we can now go on to study, because that was the last missing piece, right?
Yeah.
And we can go on to study, is there more area inside or outside? Okay?
Alright.
Alright. Good job, sweetie pie. Good job.